Do share that link again. I'm just suggesting you all to follow you guys so that more and more. Yes, Ashmi, we can start off.
Yeah. Good evening, everyone. Welcome to today's masterclass on data science. So we have with us our speaker for today's masterclass, Mr. Bhupesh, Daheria. A quick brief about sir. Yeah, Mr. Bhupesh Daheria, EdTech Futurist, educator, CEO at Aegis School of Data Science Congress, and Aegis Graham-Bell Award. Mr. Daheria is known as an education reform leader with more than 2 decades of experience in higher education, entrepreneurship, innovation, skilling, data science, AI, and telecom. His career is mainly focused on eradicating the birth penalty through offering quality education to the masses at affordable cost. He founded Aegis School of Business, Data Science, Cybersecurity, and Telecommunication in 2002 with the support of Bharti Airtel, India's top telecom giant firm, for developing the next generation leaders. A quick brief about the agenda for today's masterclass. So we'll get to know about what is data science, big data, analytics, AI, machine learning. What are the skills required to launch a successful career into this field? And what are the companies which are hiring in this field, and what are the salaries being offered? How a person with no technical or no coding background can shift into this career, into this field? What are the skills and competencies required in the market to become a data scientist? We'll also get to know the answers to the questions like, should I learn R or Python, or should I have a basic knowledge about machine learning or deep learning before entering into this field? And what are the real life applications of data science, big data, analytics, which are used in different industries like finance, operations, marketing, healthcare? Most importantly, we'll get to know how IBM and Aegis will help you to launch your career into this field. And at the end, we'll have a question answer round. So meanwhile, if anyone have any questions, you can just type your questions in the chat box. At the question answer round, we'll take your questions. And the participants who are attending us live on YouTube, we can also mention your questions in the comment box. We'll take it while having the question answer round. A quick information about tomorrow's masterclass, which is the speaker for tomorrow's masterclass would be Mr. Nabil Mehdi, Senior Data Scientist at EquaSite. So you can register in advance for tomorrow's masterclass. You can visit our Instagram or Facebook pages to register. Thank you so much. Over to you, sir.
Thank you so much, Ishpreet. And good evening, everybody. Ishpreet, just give me right to share my screen.
Sure, sir.
Wonderful. Okay, very good evening, everybody, and thank you so much for joining in this Saturday evening. So I understand from Ritin that most of you're studying in your third year or final year from across the country. And I'm certainly sure that you must have heard about these words: data science, analytics, AI, machine learning, big data, and all these words, right? So today my objective is to demystify these words, and rather than taking you deep into the definition level, I'll try to really show you and excite your interest by showing you a couple of use cases, and then we'll get into try to define. I'll talk about the history from where data science came, why it is needed. Then we'll discuss about what are the differences between business analysts, data scientists. We'll discuss about what role AI, machine learning, deep learning, and big data is actually playing in data science. And then we'll talk about what are the IT tools, the skills and competencies you require to become a good data scientist, right? Now, before we actually deep dive what is data science, let me show you where technology is moving, right? What are the couple of exciting examples, right? Start and let's see this. For example.
4 years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So, how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going. Amazon Go. No lines, no checkout. No, seriously.
This example I gave you from past. Hope all of you can hear my voice, and can you hear the sound from the video? Guys?
Yes, sir.
Oh, wonderful, right? So this example I gave you from past, and there are a lot of such stores came across the world. Amazon launched this store in Seattle in 2017. There are a lot of stores in China. India, a lot of experimentations are being done, but our stores are too crowded. And essentially, this is a perfect example of taking a decisions, automated decisions based on the data. And what is the data point? Customer is entering into the store, he is buying, and you're using multiple technologies. We'll discuss about those technologies, computer vision, right, IoT, different sensors, right? And based on the data which you're collecting from these devices, you're trying to really take a decision that what customer has bought and how much you need to really charge without the customer getting into the queue. Let me show you another example.
Good morning, all of you. Welcome to Data Congress. And today is one of the last day, and we have been given opportunity by Mr. Bhupesh to present the project. Just can I also get a good story out of it?
Vectors and the captions of it into the same vector space. So we can
what this project does that you
have generate this story. So as the caption suggests, a silhouette of a person standing in front of a sunset over.
So you take a picture, and you upload a picture on this app, and this app generates the text. This app generates the story out of that story, out of that picture. So you can take a selfie of you standing in front of a lake or maybe a tree, and then this model can really generate a story based on that picture or selfie which you have uploaded, right? Now these days, GPT has become quite popular, and these kind of applications became quite popular. But these folks, they have done long back, that was 2018, right? Such applications have become quite popular in last 1 year or 2 years because of GPT, right? So this video is already there on the internet, on Aegis YouTube. You guys can really go and check yourself, right? This is something like, let me run this video. This is exciting project which some of our students did in the last batch, last to last batch.
So first, user have to upload an image where a number plate is visible so that we can validate that this car is registered with an insurance company. So as you can see, that number plate has been detected, and this is the number plate. Second step is we have to upload an image of a car where damage is visible. So here our image classification and image segmentation model will be working in backend. So as you can see in this output image that clearly a dent has been detected in the front. And you can see that car, it is validated, damage is validated, location is front, and severity is severe. And this is our team.
So these folks, they are last batch student. They have done this project to automatically take a decision in terms of insurance on what kind of damage this car is having, right? And Tapas Mondal, if you can really switch off your video, we'll appreciate. So, so these folks, what they are doing, they are collecting the image of a damaged car, and then based on that, they're calculating how much damage it is being done and what should be the whether they can really get the insurance or not, right? Because vehicle insurance is a big business across the world, and how do we really automate that? And there are a lot of fraud happens. So this was a humble project done by these folks, right? And again, in this, the underlying theme is you collect the data and then you take the automated decisions. And that's what the central theme of data science, which we'll further discuss. Let me show you a couple of examples.
It's been 5 years since my father passed on. And the only regret I've had in life so far is that I haven't been able to spend time with him. I thought I'd do that with my mom, but she didn't want to change things and preferred living alone. So I was always looking for a way to ensure that my mother is okay. And Dozy helped me achieve that. There is no stopping my mom when she sets her mind to do something. She'll do everything without thinking how working so much will affect her health later. So that's why I got her Dozy, so I could keep track of all her vitals without disturbing her. With the updates I was getting from Dozy, I knew everything was fine with my mom. But one day, I got an alert. When I asked her, she...
This is a fantastic product developed by a company based in Bangalore, and this book is quite a young guy, hardly 24, 25 year old. And they are trying to really measure and monitor the vital stats from the remote, and this has become quite a problem during the Corona period as well. And they collect the data, they build up a hardware. So it's not only data analysis, but they have built the hardware device which can be inserted inside your mattress, and then it really collects the data and gives the alert to your relatives or even to the doctors. Right. This is quite an exciting project which was done by our two students, Devashish and Krishna Dalal. Both of them, they do not have any background in say technology or even in coding. Both of them, they have the BCom background. So this project, what it does...
Arshahar to Watson. That's a good length ball. And he gets down on his haunches and sweeps this towards boundary.
So what this project does, it automatically generates the commentary based on the video footage, right? So again, in this, you're analyzing the video and you're trying to really generate the commentary, right? And you can really see how technology and models have evolved just in 2 to 3 years span, right? So you saw the 2018 batch, they generated the story out of the image, and after 3 years, this batch has generated commentary out of a video. So these were some homegrown projects which I have shown, which students like you, those who have developed these projects, and they have got a huge real life significance, right? You might have heard about Sophia and may have seen that. Let me show you this video of a paper, which was a joint project of IBM and SoftBank.
こんにちは、ケントさん。元気ですか?
Oh, Japanese. Hi, Pepper.
Wow, there are a lot of people here.
Okay, so could you introduce yourself?
My name is Pepper. I'm a completely new species of social humanoid robot, designed by SoftBank Robotics.
Okay, so could you tell us how have you been?
It's been a big year for me. I'm working in all sorts of companies, like banks, retail stores, and hotels, to help customers have the best possible experience. I've even been adopted in homes in Japan.
Okay, so you've been very busy. What else?
Now that I'm using Watson, I am learning a lot. I can read up to 800 million pages a second, and can better understand humans' natural language. Sometimes, it's tricky for me to understand phrases that don't translate word for word. Throwing shade, for example, has nothing to do with the sun. Who would have thought?
So I met Pepper during the launch ceremony way back in 2016 in Bangalore. So Ginny Rumuti, who was a former CEO and the chairman of IBM, she came to India. And there was a launch ceremony in Hotel Leela in Bangalore. And fortunately, I was there in inauguration ceremony. And Steve, so this video is from Tokyo. It was not from Bangalore launch. So Steve invited Pepper on a stage, and the Pepper walked just like a human being and started addressing to the audience the way it is addressing in this video. And I was pretty thrilled, right? I watched a lot of movies, and just before this, I saw Star Wars. I was in kind of that hangover. And when I saw Pepper on stage and addressing to the, there were around 300 people, I had a goosebumps. So watching a robot talking in movies and YouTube is something different, and seeing them unexpectedly in front of you is something amazing experience that time. So far, so the point which I want to really convey 2-3 points. One of course that we all think about the future, that things will come in future, and most of the things which we watch in movies, we presume that they are going to be in future, but the future has already invaded into the present, and most of the things what we see in movies, they have already started happening around our life, right? And we can really see examples of that. So in last, say, 10 years, last 1 decade, the technology has grown exponentially. Right? But our learning speed is still linear, right? And we'll further discuss on that part. Now, what is the impact this kind of robot can really have on our life other than this entertainment purpose? So the day this Pepper was launched in Japan, 5,000 units were sold. So this kind of a humanoid is they're working in hotels, restaurants, they are working in hospitals, right? And the soul of this robot is essentially a software which is called IBM Watson. And IBM Watson is being deployed by hospitals even in India. Manipal Hospital signed a deal with the Watson, and doctors are training Watson to diagnose cancer patients, right? So most of the reports, diagnostic reports, are in electronic format. Every day, thousands and thousands of papers are being published related to the cancer research. And doctors do not have time in terms of really reading those papers. Now, Watson, a software like a Watson, which is like a cognitive software, or you can call it AI software, they have capability to read roughly around 700 million papers, documents, 800 million, sorry. which is roughly around 80 crore pages per second. So they can really read those research papers, they can really read these reports, and they can advise doctors or even to you what kind of disease you're suffering. And this can democratize the way healthcare is being done. So the patient need not to really travel all the way from, say, Ranchi or Jharkhand or Bastar to come down to Bombay, wait in a queue. They can upload their diagnostic report wherever they are, and Watson kind of software can really give them the recommendation, and the senior doctors can really look at those reports and can really give the comment. And that way you can really treat and diagnose much faster and a larger population. There is another company, very exciting company, Niramai. It's an India-based company based in Bangalore. And the founder is Dr. Geeta. She used to work for Xerox Research Center. And I have seen how Dr. Geeta and Dr. Manish has worked on this technology on diagnosing breast cancer. And she launched this startup company, Niramai. They raised the funding as well. And what these folks, they do, they just put a thermal camera on your mobile phone, and thermal camera costs you roughly around 25,000 bucks. An Android phone will cost you, say, 10,000 to 25,000. So 35,000 to 40,000 rupees, your cancer diagnostic device is ready, which otherwise will cost you somewhere around 20,000. ID team, please take. Can you please mute your microphone, please? Yeah. And now this device, you can diagnose breast cancer, whether you're in mall or a home, with no touch, non-intrusive, right? And it can be a good substitute for a device, diagnostic cancer device, which will cost you roughly around 12 to 13 crore rupees, which is a hugely costly affair. And so these technologies, these advancement in algorithms, these advancement in data science, AI, computer vision, machine learning, deep learning are fueling these kind of innovations. And I call these innovations these innovations are essentially helping you to take decisions which is primarily on the data, not on your gut or not on your inexperience, and take the decisions automatically at a larger scale. And that's what the objective is, right? Okay, so I would encourage, so all of you, there is a small announcement, will be inviting applications for Aegis Graham Bell Talent Hunt. And we are inviting applications from candidates from across the country, and we award 100% scholarship to students to study postgraduate program in data science, business analytics, big data, in association with IBM, plus PGP in cybersecurity, PGP in applied AI. So these three programs, you will be awarded 100% scholarship if you clear the test and if you demonstrate some kind of capability or you have done some exciting project. So do register yourself on mUni and apply for this AGBA Talent Hunt examination. Okay. So I have given you some example. So let's see some of the reports. These are the simply numbers. These numbers doesn't matter much because these numbers keep on changing, right? So the most important thing in this is this third line, right? That 80% of applications will have an AI component by 2020. 2020 is already passed. But the idea is that it's not a deadline. The idea is that majority of the applications will become smarter. And we have seen in my previous example that most of the applications, they behave like a human being. These smart applications, they are not dumb applications. And if you are to really make these smart applications, you need to use smarter technologies, which is data science, which is machine learning, which is deep learning, which is computer vision, right? So these are the technologies which you need to really use to make smarter applications which can really take the decisions at their own, right? And mimic the human behavior. We'll see it further. Another very interesting thing. So last week, this week only, almost 4 days back, I had a panel discussion on future of job. AICT organized. So the discussion point in this future of job was that what kind of skills will be required in the future. And one of the data point which was proposed by FICCI, NESCOM and EY, this report is in public domain. And this report says that there are roughly around 600 million people work in India. And close to 9% of those who are working, they will not have any job because those jobs will not exist, right, by 2022. And we can see that in last 5 years or 6 years, since you have enrolled for engineering or whatever the graduation you're doing, every time you keep on hearing new kind of jobs. So data scientist job was non-existent, say 10 years back in India, right? Even there was no course, right? So we were the first one in Asia to start the first postgraduate program in data science way back in 2015, which is not long back, but in last 10 years, the way things are growing exponentially, changing exponentially, it feels like 50 years, it feels like a half a century. So new jobs will keep on coming. So we need to really increase the pace in which we are learning, right? But some skills will be constant, of course, just like mathematics, like statistics, right? Which we'll further discuss. And what it also says that 37% people, their job role may remain same, but underlying skill set will change. Like, for example, a software engineer, the title will remain same, but the underlying skill set will change, and I'll show you how it is changing. So say earlier or even today, software engineer typically requires to have some programming language exposure, maybe Java, right? But now new software developer, those new jobs opportunities which are coming, they inherently are asking for your expertise on Python, because Python becomes a de facto tool through which you can actually build the smart applications. You can really do machine learning and deep learning, which will be a foundation for making the smarter applications. These are the couple of projects which we are running, right? So some of the projects I have given you, we are working extensively on say applying AI in education. We are running one exciting project called Kojo, and what it does, you just upload the photograph of missing children, and then it can really detect from where this children was missing, and it can send an alert to the police station, parents, and this way this can really help to find the missing children. You can really use this application to stop child trafficking and women trafficking. Very exciting project. So the idea is these tools and technologies are not merely a tool to really get you a job, but these are quite transformative technologies. They can really, you can use these technologies to change the world and make it a better place. So let me show you one interesting thing, how we are using this technology to actually analyze and design the curriculum. So this is the dashboard of a student, right? This is the demo student. Now, as a student, when you join, you need to really see what skills and competencies will be required to become a data scientist, or in this field like AI, data science, analytics. So we have analyzed thousands and thousands of jobs, and you can really see in a real time that there are roughly around 24,000 jobs, unfulfilled jobs currently in India, right? And which are the key jobs? Let's say if you want to become a data scientist, I'm clicking it over here. And you can see that this has shown you which are the skills which is important to become a data scientist. The most important skill set is machine learning, SQL, Python, statistics, R language, right, NLP. So it really gives you. So this analysis comes out of the analysis of thousands of jobs rather than individuals' biases, right? Very exciting project. And why this project is critical? Because most of us, we give advice based on our narrow experiences, right? Our own biases. So if you ask a question to a PhD in statistics, they will say that statistics is everything in data science. If you ask somebody who has done maybe software engineering, who's working as a developer, he'll say, okay, data science is only about Python, right? So if you ask somebody who's working in AWS, they will say, okay, AWS is the critical thing for you to become a good AI engineer or a data scientist. So everybody brings their own biases, but we took a call that if we have to really deliver a data science program, this data science program curriculum need to be based on the facts, the data, rather than from the human biases, no matter how expert they are, right? So I can't say that I have 26 years experience, so I know more than you. No, today, even if you don't have any experience, you can really go out, analyze the data, and you can really beat anybody's experience, right? And that's the kind of power this data-driven economy is giving you, right? So today you have abundance of data, all of us, we can really analyze and give some kind of insight. And this becomes much more important because now we have fake news, we have a lot of biased information which is coming on the social media. Everybody is quite opinionated and everybody is giving their own opinion, right? Okay, so now slowly and gradually we are moving towards data science. So let's see what are the critical questions a business asks. So whenever you will join an organization, whether you join as a software engineer, you join as a manager, company is paying you, whether it is a private company or whether it is a government enterprise, you are being paid to do some task. You've been hired to really fulfill some purpose, right? Now, let's take a business organization. Let's say you're working in Amazon. So the Amazon CEO would like to really know what is happening at this point of time. How many people are visiting my website? What people are buying? So this is called exploration, right? Or discovery or exploration. And when you have like say 160 million customers, just like on Amazon, it becomes extremely difficult to even find out what is happening, right? Now, another question which if you join a company, you need to really answer, what happened? So you release the advertisement for OnePlus, and you would like to really know how many mobile phones are sold, right? And if you want to really find that answer, you need to again analyze the data, right? So you need to really, if the data is small, you can really analyze in Excel sheet, or if your system is running data is in SQL, you need to run the SQL queries, or if the data is pretty large, maybe from the data lake or maybe from the Hadoop cluster, you need to really find out answer, and that's called a descriptive analytics, right? So these questions were prominent 50 years back. These questions are prominent today, and these questions will remain prominent even after 50 years. So we'll understand these questions, and we'll now later on we'll understand how we are going to really answer these questions. Now, the third most important question is, why did it happen? So, for example, you estimated that you will sell 20 million mobile phones, but you sold only 10 million. So you would like to really know that why did it happen? Why we could not really sell 20 million? Or let's say you visit a doctor and you say that you have a throat infection, you have a fever, doctor runs some diagnostic, writes some test, and based on that, doctor tells you that yes, you have a fever, or maybe you have a corona, or maybe you have throat infection, or maybe you have a flu, right? So that's called diagnostic. So next question comes, what will happen if the doctor does not treat you? If the fever is 102 degree, what will happen? So the doctor predicts you, right? And after that, doctor writes you the prescription. So let's say in a business case, so your team did the analysis and said, okay, you, before even the launch, you tell your team to identify that how many mobile phone we will be able to sell on, say 35,000 rupees, Android phone. So your team does some analysis and does the predictive analytics and find out that how many mobile phones you're going to sell. So their prediction comes out that you will be able to sell only, say, 500,000 devices, wherein your target is to sell, say, 2 million devices, right? Otherwise, you'll not make a profit. So then you need to really go back and find out that what kind of corrective measures you need to really take, reduce down the price or improve the spec, or you need to really run more advertisement on social media, right? So these are the questions which you need to really answer, that what is happening, what happened, why did it happen, what will happen, and what we should do, right? So most of your life, you will be paid if you're working in any data science or analytics company to answer these kind of questions only, right? You were answering these questions even, say, 20 years back or 30 years back, but that time you were answering these questions based on the small data, right? Today, the amount of data is humongous because all of us, we are connected over internet. All of us, we are using mobile phone. But today, out of 7.2 billion people, roughly around 5 billion people are having the mobile phone and 3.5 billion are having the smartphone. In India, out of, say, 130 crores, like almost 90 crores are having the mobile phone. Of course, the mobile SIM number is more than 130 crores, right? So most of us, we are on social media and we are generating the massive amount of data, and that data cannot be stored on Excel sheet. So although the business use cases have not changed, the questions business is asking have not changed, but to answer those questions and improve the accuracy has drastically has gone into a different domain, and you can't really so easily find these answers. And that's led to actually growth of data science, right? So any questions so far? Please feel free to ask any question if you have in your mind. Okay, so I kind of set up the context that why we need to do analysis, because these are the questions, very critical questions, which business need to answer so that they can run. Even in the government, let's say in India, we hardly 2.5% to 3% people pay income tax, wherein 15% people can really pay income tax. If 15% people pay income tax, this country will become better than US, and you will not apply for the US visa, not try to really migrate to the Canada. But how do you really identify who are doing the tax evasion? So Government of India has launched a project, iInsight, almost 5 years back, and they're trying to really combine the data of those who are paying income tax, those who have the Aadhaar card, those who have PAN card, and trying to really identify those who are trying to evade the income tax. And in the last couple of years, millions of people are receiving the notices income tax, and income tax collection is increasing. So even the government wants insight, right, to safeguard this country, to improve the better tax collection, right, to protect this country. You need insight. So let's understand what is data science, right? So as I explained you, that you need to really find out the answers of these questions. And it's not that people were waiting that data science will come and will answer. Business analysts were answering these questions. But after this whole internet era, which started in mid 90s, and that is when Amazon, eBay, Google, all these companies, they were started. And the data started increasing, and post 2000, we have started seeing the large amount of the data. And before that, most of the analysis was done on Excel sheet because the data size was small. But post 2000, early 2000, we have started collecting a lot of data, which is log file, which is images, which is video, which is sound, right? So we were collecting all kind of data. And 2005, Facebook came, YouTube, it started becoming quite popular. So there was a lot of internet data which was started coming. Of course, telco companies, telecom and financial banks were earlier even generating the large amount of the data. But that data was more of a structured data. But these companies started a lot of generating unstructured data. And most of these companies, if you see Facebook and Google, how they make money by showing you the advertisement. So if you want to really show the right kind of advertisement, you need to really know about the customer. And you need to collect more and more amount of the data. And that's the reason Facebook does not delete any of your stuff. So whatever the crap you want to really upload on Facebook, Facebook keeps on storing so that Facebook can create profile about you based on the images you're uploading, based on the videos you're uploading, based on your like. Facebook can really create your avatar, and Facebook knows precisely well that which advertisement need to be shown to you. If you click on the advertisement, or if Facebook shows you the advertisement, the client pays money to the Facebook, and that's how Facebook makes money, or that's how Yahoo or Google or everybody makes money. Amazon makes money by showing you the better recommendation, right? Which if you go on Amazon's website, they always give you right kind of product recommendation. To give you the right kind of product recommendation, the advertisement, these companies need to have better insight about you, just like your mother. So your mother, even before you opens up your mouth, the mother is able to really tell you what problem you have, because she has started collecting the data even before you were born. So as a human being, we also develop the insight based on the data, which our powerful brain processes and churns out the insight. Now, so we are naturally capable of analyzing all kind of unstructured data, which is sound, voice. I can really see with my eyes. You guys can really observe my body language, right? You can really see and you can really take your own conclusion. But machines are not capable of comprehending this complex kind of data. And so before 2000, most of the business analysts, and even today, most of the business analysts, they are still analyzing a lot of structured data. So the moment we think about the data, the Excel sheet comes into our mind, right? Which is row and column data, right? So one column, there is a name, then the age, right? Gender, income, address, and all this kind of stuff. So we have typically a structured data. And that's the notion we have about the data. But data is a pretty large. You have unstructured, you have structured. Unfortunately, across the world, you have roughly around 90% of the data is unstructured data. It's not a structured data. And if we analyze this unstructured data, we can really monetize that. We can really do a great deal. And that led to the evolution of data science. So there were two gentlemen, Jeff, who used to work for Facebook, and there was another guy, DJ Patil. This guy, he used to work for LinkedIn. DJ Patil eventually became the chief data scientist for US government. So both of these guys were doing some data analysis job. So one fine day, they realized that this data science, this business analyst, data analyst designation does not suit to them, because they are not analyzing simply structured data. They were analyzing unstructured data, and they were building up the data products as well. So they coined this word called data scientist, and not only they coined this word, they also crowned themselves with this word. And this happened in 2008, and this whole data scientist word spread like a fire in Silicon Valley, and everybody was holding a PhD, and those who were doing data analysts and data business analytics job, they all started catching this data scientist designation. So data science is basically much more evolved form of a business analytics, right? And you apply data science for typically large volume of the data. Does not mean that you do not apply data science for the small data, right? So that's a brief history about data science. So this is a wonderful article in 2012. Dr. DJ Patil wrote in HBR that data scientist is the sexiest job of 21st century. There's nothing sexiness in this job other than the kind of money you make. This is a quite challenging job, and 80% of the time you will be devoting in terms of cleaning and finding the data, right? So here is my definition about data science. So as I have set up the background for you, data science is basically much evolved from the traditional analytics, right? So, and this analytics, when you apply on the large volume of the data, and since big data has got a lot of variety, because it's not only the structured data, row column data, you have music, you have a video, you have images, you have a log data, you have a text data, right? To analyze, say, text data, you require natural language processing, which is the subset of AI. If you have to analyze the video and images, which in earlier two applications which you have seen, Amazon Go, the cricket commentary, the story generation, which our students have done, and even this damage car prediction, all these applications we are using image data and video data. If you have to really you analyze the image and video data, you need to use computer vision. Computer vision is again subset of AI. And you need to really find the pattern in this data, right? And that's where you will use the machine learning. So the idea is, if you have to really analyze this data, big data, and the data which has got a lot of variety, you will be using a lot of AI tools, right? And what are the AI tools? Machine learning, deep learning, computer vision, NLP, right? So the modern data science, though it is a evolved form of traditional analytics, is basically traditional analytics plus AI plus big data in a simple term, right? And that also shows you what is the relationship between data science and AI. So data science is not a subset of AI, neither AI is a subset of data science. Is that data science is a basically technique which analyzes data, and to analyze the data, data science uses various AI techniques. That's how, in simple words, you can put it. Data science, in a nutshell, is basically a science of it's about making the sense out of the data. The only problem over here that the data is a large data, and there is a variety in this data, right? It does not mean that you will not apply data science for only a structured data, right? You will do on the structured data, but you can also apply use data science for unstructured data or the text data. Right? The another definition of data science is all about automating the data science, right? So as we have seen, data science is about finding the sense in the data, right? So data science actually automates this whole process, right? And let's see how it does that. So all of you have seen this kind of stuff when you go on Amazon or Snapdeal or eBay, right? So you search for a gray shirt, it gives you the recommendation of gray shirt. It doesn't give you the recommendation about pink or a green or other shirt, right? Because it behaves like a shopkeeper which is there in a shop, right? So this recommendation system is a machine learning model, right? And it behaves like a human being. It gives you a recommendation the way human can really give you. So how do we really automate rather than doing it manually? How do we really automate this whole process of giving the recommendation to human being without the human intervention, right? So you are taking a decision which is at the back end is based on the data, but you are giving the recommendations without any human being, right? And that's the kind of, say, automating the whole decision making or analytical process. So data science has got two components. One is basically analysis of the data, and the other component is basically data products. So data products also fall in category of, you can really call it as AI products. And the first part is data analysis, like how many patients India can really have in COVID patient we can really have in, say, in April 2022, right? what is the effectiveness of vaccination, right? What are the breakthrough rates in India after vaccination, right? Or what is the positivity rate of vaccination in India? How many cars Mumbai will have, right? In the next 5 years. So all these questions you need to answer, and you need to really analyze a lot of data. Not that everything you will create the product, but you create the product wherein you have to really take the say routine analysis every day or every hour or every minute or every second. So you say, okay, let me automate this whole analytical process, and that becomes essentially a data product, right? Which you have seen in damage detection in a car, right? Which you have seen, say, commentary, right? which I have talked about, like diagnostic of breast cancer, right? So let's understand what are the skills and competencies you require to become a good data scientist. So data science actually borrows things from multiple fields. It's an interdisciplinary field. So you need to know linear algebra, statistics, mathematics, probability, right? Calculus to know a good data, become a good data scientist, because at the end of the day, every analysis is mathematical analysis, right? So these algorithms which you see, these algorithms are nothing but these are the mathematical models wrapped inside Python or a Julia or a Java, right? And machine learning is a way through which you can really add wings to your mathematical modeling, right? So it automatically finds the pattern, and so the base of machine learning is calculus and statistics, right? So you need to be good at stats, math, probability. Like in machine learning, you have regression, and regression is there in statistics for last 200 years. So I said there's a couple of things which will not really change, right? The another important aspect is you need to know a lot of IT tools, which could be R, Python, Hadoop, Spark, right? You need to really learn how to deploy models on Amazon. You need to know GCP. You need to really learn some tools on data robot, right? And of course, domain knowledge. Like, for example, if you're analyzing the cancer data, you need to really have understanding about what leads to the cancer. If you are analyzing the fraud data for a bank, or whom you need to really give a loan and whom you need to really reject a loan, you need to have some understanding about the banking domain, that how bank give the loan and on what basis they give the loan. So little bit understanding about the domain is important, but as a fresher, you need not to worry about the domain, because while you will be working in a large company or even a small company, you'll have a lot of domain experts, those who will be working with you and help you to really pick up those lingos, right? At Aegis, we give you a couple of elective courses through which you acquire the domain knowledge and by doing the projects, right? And mentor helps you. Now, where data science is being applied, data science is being applied in manufacturing, telecom, e-commerce, social media, banking, finance, IT, retail, healthcare, almost every field, right? Telecom companies use it to predict churn. We did churn prediction for 2 large telcos for roughly around 10 million customers. You do it in banking and finance to identify which customer need to be given loan. If you do the credit card transaction, which credit card transaction need to be declined, right? Because millions and millions of credit card transaction is happening every second, right? So how do you really automate this whole fraud detection stuff, right? So you use a lot of anomaly or fraud detection algorithms to really identify that. A lot of fintech companies have come up across the world, and specifically in India, and they try to really give loans to those who do not have any credit history, like a simple history. How do you really give them the loan? How do you disburse them the loan? So these kind of models, these companies are using. Manufacturing, predictive maintenance. So in my first job, we used to do the periodic maintenance. I was an optical fiber plant. So we used to really check machines and do the maintenance every in a periodic time interval. But now in Industry 4.0, the concept has come that you don't do the periodic maintenance, you predict that when machine is likely to really go rogue, right? And then you try to really do the maintenance. That's kind of predictive maintenance. And you collect a lot of data which comes from the CNC machines and IoT sensors. E-commerce companies are using for doing the recommendation, which I have shown you. They are trying to really use for personalization, which email need to really go to which customer. Netflix is using to give you the right kind of recommendation of movies. And Netflix even try to really identify which users like which kind of color, right? So even two users have a pixel distance. So you may like maybe black colors, somebody may like the reddish color, right? So they will try to really use. So for every movie, every series, they create say 5, 10 or 20 thumbnail to promote those series and movies, right? But which thumbnail need to be shown to which customer, and that is determined based on in past which kind of thumbnail color these folks have they clicked, right? So if they were clicking the red thumbnail, perhaps the next time they will also like to really click a red thumbnail rather than the blue thumbnail, right? So that level of analysis is being done across the various industries. So data science includes like a data integration, distributed architecture, automating the machine learning, data visualization, because you need to really visualize the data. You need to create the dashboard. We did a data science project for a company called Ion Infotech, which is the leading internet service provider in Bombay. And we created a big data infrastructure for them, and we created a dashboarding and data visualization, and later on we did the machine learning project, which is Churn, right? And data engineering is also part of that, and that's the reason you have to really know a little bit of the big data. Of course, data engineering is emerging as a separate field, but as a data scientist, you also need to really know from where the data is coming, right? So you need to really have some understanding about the big data infrastructure, because in India, a lot of companies, they do not have any data infrastructure, right? So if you are not having understanding, if you have an understanding, then you can really rope in those big data consultants to create the infrastructure. And once the infrastructure is being created, you can really take the data and you can really start building up the model. Not every company, just like America or large companies, will have the ready data to really work and build the model, right? Deployment in production mode, and you have to really, if you really build some model, you have to really deploy. Just like, for example, recommendation system you have built, it is a bunch line of naked code in Python. It does nothing but if until unless you deploy it on the cloud, right? So if you deploy it on the cloud, you take the API and consume it in your mobile app or a web app, and that's how the customers are going to really see the magic. So you need to really also know how to really do the deployment, maybe on Microsoft Azure platform or GCP or AWS, right? And automated data-driven decisions. So data science is pretty vast field, right? And a lot of people, they ask questions on Quora and various platforms that what is the difference between data science? And I see a lot of crazy answers. You don't have to really fall prey for that. You don't have to really debate what is the difference between data science and AI. You need to simply understand that data science is a method through which you find the insight in the data and use a lot of AI techniques to do that, right? It's as simple as that. It's not a versus against, they are not the subset of each other, right? So any questions? Let me take a pause over here and ask you questions if you have any questions. And then we close our session, and then next perhaps session, I will try to really talk about, say, AI and machine learning and deep learning. So let me pause my session right over here and on the data science only. If you have any questions, guys, feel free to really ask me. You can really unmute your microphone and you can ask me. And in case if you have no questions, then we can really close our session. So thank you guys. Thank you so much for your time and your patience. Hope this session really helps you, right? To get some basic understanding and the framework what data science is. right? Okay, thank you so much, Ishmael. Thank you, Ritin. And thank you, everybody.
Thank you so much, sir. Yep.
Okay, have a nice time. Okay, bye-bye.